Okay, today's essential question: how do we know lines are parallel or perpendicular? And how is that information used to write equations of parallel or perpendicular lines? So we've talked a little bit about parallel lines. So we're going to continue with that idea and then use that information to actually write an equation. And then we're going to go into perpendicular and look at how to use the same similar information to write equations for perpendicular lines. So don't forget to set up your notes in Cornell style. So you should have the line going down the left side of your page, giving a column to write in questions. And then you've got the line at the top of the page that separates the essential question from the rest of your notes. So starting with parallel lines. So remember, there were two things that needed to be true for lines to be parallel, and we're going to use those ideas to help us write the equations. So hopefully you remember that you need to have the same slope and different y-intercepts. So to make lines parallel, the slopes have to be the same, but the y-intercepts have to be different. So let's take a look at an example. We are going to write an equation of the line that passes through the point -3, 3 and is parallel to the line y equals -2x plus 1. So, first idea, parallel lines. The way we know lines are parallel is that they have the same slope. So look at the line that's given, identify the slope of that line, and that's the slope that you want to use to write your new equation. We're going to write a new equation, a different equation that's parallel to the one that's already given. So now we have a slope of -2, and then we're going to use the given point, -3, 3, to write a new equation, an equation of a line that's parallel to the one that's already given. So y equals mx plus b. You could start with a couple different formats. We're going to start with this format this time. And then plug in the information we have. So remember, the point gives us an xy value. The only thing we need to find for this equation, we already have the slope, but we need to find the b. So we're going to use that given point, those xy values, the slope that's given, to help us find the b value. So then you just solve for b. So we have 3 equals 6 plus b. Be extra careful with your positives and negatives. Subtract 6 from both sides. You get b is equal to -3. So then we write our final equation. Y equals, plug in the slope, -2x, and then plug in the b, which is -3. This line is parallel to the line that was given before. So those are parallel lines. So look at those two equations and identify how are the parallel lines different. Hopefully you recognize that they have the same slope, so that's how they're the same, but the y-intercepts are different. We have a +1 here. That was the original equation. The parallel line has a y-intercept of -3. The y-intercepts must be different. So you have the same slope, different y-intercepts. This line is parallel. Next, we're going to take a look at perpendicular lines. So let's discuss a little bit about what perpendicular means. So if you're given a line like this, so that's a line, and you can put it on a coordinate plane or not, then the perpendicular line would be the line that forms a perfect 90-degree angle with the line that's given. Okay? So let me do that in a different color. So we've got it in red now. So that line going through forms a perfect 90-degree angle would be the perpendicular line. So note a couple of things about those lines. So note what the slopes look like. Okay, so if you look at the blue one, the slope is, okay, if we look at the blue one, the slope is a little more flat. Okay, it's not as steep. Where the red one, the line is much steeper. Okay, so that's one thing. The steepness of the two lines is a little bit different. Also, if you look at the blue one has a positive slope. If you look at the red one is going the other direction. It has a negative slope. So hopefully looking at what makes two lines perpendicular will help you remember how to get perpendicular lines. So the idea with getting perpendicular lines is that the slopes are negative reciprocals of each other. So you have to change the sign, that's the negative part, and the reciprocal means flip it. Okay? So if I have a slope of 2/3, then my perpendicular slope, and this is the symbol that we use for perpendicular, an upside down capital T looking thing, kind of looks like the two lines I just drew above. So this means perpendicular. So the perpendicular slope would be the opposite and the reciprocal. So you change the sign and you flip it. So let's do one more before we look at an example. So if I have a slope of -3, remember the -3 is the same as -3/1. That's going to be helpful for when we do the perpendicular slope. So the perpendicular slope would be the opposite. So since the original slope is negative, the perpendicular would be positive, and you're going to flip it. So that makes it 1/3. So that would be our perpendicular slope. So it's the opposite reciprocal, or negative reciprocal. So you change the sign and flip it. So let's take a look at an example. We have a point and an equation. It says write an equation of a line that passes through the point 4, -2, and is perpendicular to the line y equals 4x plus 2. So we want to make sure that it's perpendicular to that equation. So just as before, you identify what the slope of this line is. So the slope of this line is 4. We want the perpendicular slope. We're going to write an equation of a line that's perpendicular. So remember what we just looked at above. Perpendicular lines, their slopes are negative reciprocals. So I have to change the slope I have, the 4, to a negative reciprocal. So this is already positive, so you're going to change it to a negative. And then you're going to take that 4 as a fraction, 4/1, and flip it. So 1/4. So that's the slope that I'm going to use to write my equation. So I'll use a -1/4 slope and the point 4, -2. So we're going to use those two pieces of information to write our equation of our line. So y equals mx plus b. Plug in my slope. Y equals -1/4 x plus b. Now all I need to do is find the b part. So to do that, we're going to use the point that's given. This is an x and y value, so you plug the y into the y spot. So that's our -2. -1/4. Plug the x into the x spot. So the x number is a 4. Plus b. Solve for b. So -2 equals -1 plus b. Okay, so if this is 4/1, the 4's cancel, so it's a -1 when you multiply. Then add 1 to both sides. So -1 is equal to b. So b is equal to -1. Now we're going to write our final equation. So we're going to finish this equation that we started. So y equals -1/4 x, and my b value is -1. This line is perpendicular to the line that we were given before. So that's our answer. Y equals -1/4 x minus 1. Now, we have a couple practice problems here. So there's one where you have to write a parallel line. There's another where you have to write the perpendicular line. So you should have an example of each. We just did one of each. And then after you've answered those two questions and wrote those equations of those lines, then I want you to answer the essential question. So I will be looking for this. This would go on the left side of your notebook. Your notes that you just took should be on the right side of your notebook. And then answer the question after you've solved these two problems. I will be looking for these when I come around to check your notes. And I'll see you in class.